Good afternoon and welcome to the CERIAS Security Seminar from Purdue University. Our speaker today is Koenig from University of Illinois at Champaign, but he's a visiting scholar there from the Technical University in Darmstadt. His topic today is security in infrastructureless decentralized systems. Andre.
Okay, thanks a lot for the introduction. Thanks for inviting me. I thought I would try some different kind of motivations. So let's see what security in infrastructureless decentralized systems has to do with this jungle. So starting a talk on communication networks with something like, by now communication systems have found their way into many areas of our everyday life, would be quite legitimate, I think. But for two reasons it won't work for this talk. And the first reason is exactly this way. So when we're talking about the way, we're talking about something like infrastructure. So for communication networks, this would be wires, routers, access points, wireless access points, but also cellular base stations. So communication networks today, when you think of wireless communication, are well able to live without these infrastructures. And that's exactly when we are here. So let's shortly go back to the infrastructure part and talk about security. So for our well-known infrastructures, communication infrastructures, we are quite secure within these. So we have defined authorities, we have defined means to control access to these infrastructures, and we have defined means to detect and deal with misbehavior. So when we leave our well-known communication infrastructures for which we know security mechanisms that will work, we're confronted with new challenges. So maybe new types of misbehavior, and maybe for these types of misbehavior, the security mechanisms that we defined will not work anymore. So the second reason why this introduction would not work for this talk is the everyday life. So I'm not going to talk, and I will just want to show this very short in one picture. I'm not going to talk about communication networks for our everyday life. So to wrap this up, I'm going to talk about peer-to-peer systems on mobile ad hoc networks. So in fact, the decentralization and lack of infrastructure on the whole network stack, and this combination is mostly mentioned in the context of first responder scenarios. So scenarios where communication infrastructure is not or not anymore available. Within these scenarios, we have specific properties. So in general, they are highly dynamic, so we have a constantly changing topology. We have no communication infrastructure as said, so we need the wireless transmission to connect the devices, and the functionality of the resulting network will be based on cooperation. This means if we want to have a communication between two nodes that are not in direct transmission range, then we require nodes in between to relay the communication appropriately. So from the perspective of security, this is challenging because it means that we won't have well-defined network borders. So nothing that we know from infrastructure-based systems that can be protected by means such as gateways or firewalls, for example. And we won't have central trusted instances, so something upon which mechanisms like public key infrastructures or authentication, accounting, access control, Kerberos is based on. So to conclude the motivation, we can say that with the decentralized infrastructureless systems, we can offer communication beyond today's communication networks, beyond wired, fixed, infrastructure-based communication networks, but we are also beyond the protection of today's security mechanisms. And these are exactly the challenges I will talk about in the following. So I will talk about security mechanisms, novel security mechanisms for peer-to-peer systems and for mobile ad hoc networks. For both areas, I will introduce shortly the basics just to get us all in line with the foundations we need to understand it. I will show evaluation results, and I will show models, testbed experiments, and I will talk about the challenges we have when we want to evaluate new protocols, new mechanisms for decentralized and infrastructural systems. So if you have any questions regarding the understanding what I'm saying, feel free to ask at any time. So let's start with security in peer-to-peer systems. Just for the basics, the challenges in peer-to-peer systems, two main challenges we have is how do we perform service lookup and how do we offer security. That's what I'm going to talk here. So just to compare it with client-server systems, there we have a very clear role assignment. We have servers that offer services and we have clients that consume services. And services such as service lookup, so if I'm looking for some content in a client-server system, I will have servers that are in duty for this. So when I'm talking about World Wide Web, I will have something like Google. When I'm talking about service-oriented architectures, I will have some service repositories maintaining directories of the services available. In client-server systems, also the security mechanisms are offered by servers, by central trusted instances. So, for example, public key infrastructures for key management, for mapping identities to a communication network, to cryptographic keys. And for example, something like Kerberos for authentication, access control, and accounting. So in peer-to-peer systems, we do not have these role assignment. We have services offered and consumed equally by the peers, so no servers, no central trusted instances. Main questions is how can we perform service lookup, how can we offer security mechanisms. Just for the service lookup, because we will need this in the following one slide, there are 3 ways to do this. First one is unstructured peer-to-peer systems, and here a peer just joins, and if I want to access services that are offered by the peer, I will just broadcast a request in the whole peer-to-peer system. In hybrid peer-to-peer systems, there are some super peers defined to which I announce services, and when I'm looking for a service, I will address a super peer and ask, hey, which peer offers me this service? So problem is, how can I assure that my request for a service would reach the appropriate peer, and how can I make sure that I will really discover all services that are within the network? And both is a bit challenging for unstructured and hybrid peer-to-peer systems. So what I will use in the following is a structured peer-to-peer system, in fact pastry. These are based on distributed hash tables, so these work quite like phone books. If you imagine peer-to-peer system, structured peer-to-peer system consisting of, to make it easy, 26 peers with the IDs A to Z, then peer A will be responsible for services that start with A. So if I'm looking for a service that starts with A, I will exactly know which peer to ask for, and he will have the information on which peer this service will be offered. So just for the performance, pastry offers a prefix-based routing. In general, structured peer-to-peer systems offer routings that are based on tree structures or ring structures, and within these we have a logarithmic lookup time with respect to the peers, total number of peers that are in the system. So what I'm considering in peer-to-peer systems are cooperative decisions as a replacement for missing central trusted instances. So if we do not have central trusted instances available and want to decide on security-related requests, we have to make sure that we need a way to decide on this, and we have to make sure that not one single peer is able to decide on a security-related decision. So not one single peer should be able to grant access to restricted resources. So, and for this we need, on a technical level, some means to distribute cryptographic operations. So in fact, not a single peer should be able to sign some certificate that grants access to restricted resources. What we use for this is threshold cryptography. This is based on Shamir secret sharing. It's in fact a way to distribute the keys. So you define a polynomial such that the value of the polynomial at point 0 equals the key you want to distribute, and what you give to the peers are values of the polynomial at specific index values, and depending on the degree of the polynomial, a certain number of peers have to interact to perform cryptographic operations. So for peer-to-peer systems, if we talk about signing certificates, what will be done is to have partially signed certificates signed with the key shares that can be interpolated to a fully signed certificate if you have